Okay, we're now looking at cause and effect, correlation, and other related variables. So this is trying to tie everything together now. So one of the things that's important to know is that cause and effect is a very specific thing. So we can only prove this when we've done an actual scientific experiment. And this is what we'll do as our fourth topic for the year. So you've got to be very, very careful. Unless it has been designed as a scientific experiment, you cannot prove it. Correlation, that's what we've been doing in this topic. Okay, we've been looking at, is there a relationship or a correlation between two variables? And when we look at related variables, that's looking at other factors and this particular idea of lurking variables. So when I'm looking at cause and effect, we've got a number of reasons why we can't do this. So a formal experiment is where we have every single other variable is being held constant except for the one that we're trying to investigate. So this is how we can prove that something causes it, because we've made sure that everything else stays exactly the same. If we're just observing some data, then obviously we haven't held every other variable constant, and that's why we can't prove cause and effect except if it's done in this very specific way. So it's also often hard to know what direction the causality goes in, so which variable is actually causing the other one. And there can often be a third variable behind it all which causes things that we see. So here's an example. A person could have low self-esteem, and that low self-esteem could cause them to get depressed. Or somebody who is depressed, that depression could cause them to have low self-esteem. Or a third explanation is that there is another possibility, a lurking variable, so some other distressing event or a biological predisposition causes somebody to have both low self-esteem and depression. So when we see that there's a relationship between low self-esteem and depression, there are a number of different possible explanations for why that happens. And this is why we have to be very, very careful about that cause and effect, because we know it could cause, this could cause that, and this could cause that, but we don't actually know which one actually causes it. So here's a couple of examples for you. If I exercise, then how much calories I burn per minute is going to increase. So even if I'm sitting down doing nothing, I'm still using energy and I'm still burning calories. But if I exercise, I burn more calories. So that means that we have a positive correlation. So as I do more exercise, I burn more calories. This can also be causation, because the doing exercise, using my muscles, causes the calories to be burnt up. So that's an example of causation. Whereas the second example here, I've noticed a relationship between the number of firemen fighting a fire, and as the number of firemen increase, the size of the fire also increases. This is not a causality one, because bringing more firemen to the fire is not going to cause the size of the fire to increase. In fact, it's often the other way around, is if there is a bigger fire, we need more firemen. So in your discussions for your assessment, there's a number of things you can discuss. You can look at how you've found a correlation but not necessarily found causation and explain that. You can also discuss how the correlation that you have found could be due to a lurking variable that explains or causes the effects that we are finding. We could even possibly suggest some possible lurking variables, or consider other related variables that might be correlated. So have a look in the data set that you have got, and often there are multiple variables in that data set, and you can try looking for some correlations in those other variables. So if we go to our fuel efficiency by weight example, we've found that there's a correlation between the fuel efficiency and its weight. And we found that that correlation is strong, negative and linear. Okay, so that's what we found back in the first booklet. So in terms of cause and effect, I would say that we can't claim that there's a causal link, because it's possible that there's another variable that explains both of what we see, that explains that correlation between the weight and the fuel efficiency. So for example, if I look at the graph here of price by weight of cars, and I notice there that this is a moderate relationship, it's a positive relationship, and there's a linear correlation. So I found, compared to the weight of the car, price is also correlated to the weight of the car. So that I want to be able to comment on that and say other related variables. I found a moderate positive linear correlation between price and weight, and that indicates that cars that weigh more tend to cost more. And now I need to think of the story behind that. So why do cars that weigh more cost more? And so it could be because that as cars weigh more, that we've added more features to it. So it could be that it's using more car stereo systems, that there's security systems, things like that. So there are other features being used, or it could be that there's different types of products. So metal versus plastic, aluminium, etc., etc., and that causes the price to increase. But it could also be the fact that they need to use more metal and more plastic to make the car, because the car itself is bigger, the weight is heavier, therefore it takes more of each component to build it. So because you've got bigger windows, you need bigger and heavier panes of glass. So there's a few possible explanations for the relationship that we see there. I've also gone and had a look and found that engine size by weight, if I compare the engine size and the weight of a car, that looks like there's some kind of relationship here. And I noticed that this is quite a strong, positive, linear correlation between the size of the engine and the weight of the engine. So as the weight of the car increases, the engine size is also increasing. So that means cars that weigh more tend to have bigger engines. So what does all that mean? Well, it means that the size of the engine might have an effect on the weight and the fuel efficiency. Because remember, that was my original investigation. And if I've got a lower weight car, they've probably got smaller engines. And the design of those engines, because they're smaller, the design might be a lot more straightforward. And so therefore they are more fuel efficient because they don't need to have as many moving parts. And it's also possible that the cars that weigh a lot have quite different types of engines. For example, diesel versus unleaded petrol. It could be, 6-cylinder versus 4-cylinder versus, I don't know all the other things about cars yet, but there's all sorts of other things about cars that are different in bigger and smaller cars. And an extension on that is we've got biofuel now, and we've got electric and hybrid cars, and so that is changing this fuel efficiency argument quite considerably as well. So there's lots of other variables that I haven't listed that might be related. So we certainly have to be aware of those variables. And the variables that I've described, I've looked at the engine size and the price. Those are not an exhaustive list. It's not all the possibilities. But I have found that there are these other relationships that are also connected to the weight of a car. So when going back to my original purpose, I was looking at buying a car. So when I purchase a car, I need to take all of these different things into consideration when making my decision. And that would be an excellence level answer to exploring cause and effect, causality, and other variables.